So this section is about array. I guess you know already. If you join the computer programming, it's not difficult to understand about the array. But this is one of the data structure that we need to understand. And especially we need to know how the array will work and what is the type of the array operations. And at the end, now I will discuss about the growth of an array and some strategy when the array is growing. The Python have one sequence classes. Okay? Not one, but several sequence classes like list, tuple, and string. So string is also one class to understand about the sequence of character. So character means one letter. So if I call str, so it means there are three letters, and each of the letter will be in one location or in one index. You know list. List is one of the sequence. Um, it is also kind of array. When you put one element, the element will be located in the index 0, index 1, index 2, and so on. The same with tuple. Both of them are the same. However, they are different. List can be modified. Tuple cannot be modified. So those kind of sequence, yeah, it is we have the index. Okay? We have the index for every element. So if we call it AI, it means I means the index. I can be from 0 until n. Okay? So for example, this one, let's say this is A, is an array, and then the index starts with 0. And then I have index I in any position, and then n means the number or the size of the array. So the size of the array, usually it is fixed. It is not growing because whenever you have an array, you can set like the array amount will be 6 or the array amount will be 20. So this kind of n will determine the memory location. Whenever you define the amount of array, computer will assign a very specific address or very specific memory location for every of these elements. Okay. So if we are doing with the character like this one, okay, we have SAMPLE. Okay. So this is a very simple or compact array. We call it this is compact array because one location has only one element, and it is a character. It is a character. There's also there's another kind of array. We call it is an object. So index 0, it is a string. Index 1, it is another string. So this is what we call as object. So whether the array includes a character or it is an object, okay, it is different about the purpose. So in the compact arrays, or we would like to use with the primitive data type, we have the module array. So in the in Python, you will see there is one module about array, and this array is different with list. In the list, you can use any kind of data type. You can use number, you can use character, you can use string in one list. But array, it is only for a specific data type. So primary support for compact arrays is in a module named array. That module defines a class. The class name is array, and it provides a compact storage for arrays of primitive data type. Do you understand what is primitive data type? Primitive data type is like integer, float, character. Okay? We call it primitive because it is the very basic data type. The constructor of array class requires a type code as a first parameter. So like this one, we need the type. Data type is I, means integer. So we can define with other kind of type. Later I will explain. And then the next will be the data. So for example, I put one variable primes, and the variable primes will contain integer value, and the integer value will be in a list which is 2, 3, 5, 7, 11, 13, 17, and 19. Okay. And those will be in the format of one array. So there are some codes in Python. For example, B. B is a signed character. Big B is unsigned character. U, Unicode character. H, signed short integer. H, big H is unsigned short integer, and so on. Okay, you have small I, big I, small l, big L, F, and B. Okay. So do you know what is the difference between signed and unsigned? We say it is signed character if we have the positive or minus. So for example, there will be a negative integer. Okay. So here integer, there will be a negative integer. And also in the character, you will have some more characters with symbols. Okay. So the symbols will have like the unsigned character. For the integer, if you distinguish between negative and positive, then you need to use sign. If you just have only positive, then you can just use unsigned. In the array, there are some operations, and I think this kind of operation will be the same with all kind of data structures. The first is insertion. So in every data structure, you need to understand how to insert the data. In the array, we have one operation, we call it add, or it is a function. And then I is the index, and O is the object. Okay. Just to remember, I means the index. O, it can be anything. If it is a primitive data type, then it can be a number, integer, float, or character. If it is an object, it can be your name, or it can be student ID. It can be an address. okay, full of characters. Okay. So when we have the operation at I, comma O, I want to add a new data in the index I and put the object O. In an add operation at I, comma 0, we need to make room for the new element by shifting forward the n minus I elements. Okay. So if I want to insert into this I, it means I would like to make this empty, and then I will move this element to the next. I will move the next element to the next. I will move the next element to the next. I will move the next element to the next. I will move the next element to the next. So it means there will be a new n, and the new n will be n plus 1. Okay. So in this case, if I want to add one object into the index I, if the I equals to 0, then the worst case will be ON. Can you understand this? So if I want to add an object index in index 0, then you need to move from this one to this, from this one to this, from this one to this, from this one, from this one to this, and so on until n times. Okay, so that's why it takes ON time. So the object O will be in index I, and now n is moving plus 1. Okay. Now if I want to remove, I want to delete. Okay. If I need to delete, let's say I want to remove the index I. Okay. So the index I here is this one, and we just have the object O in index I. When we delete one object here, we need to make sure that there will be no element which has no value. So we need to fill in every element from index 0 until n. Okay. So if we want to remove this one, it means once we delete this element, then the later part element should go here. The later part element should go forward. The element here should go forward. Here should go forward. This should go forward. And the new n will be n minus 1, because we want to reduce or remove one element in index I. So the element will be like a plus 1 until a minus 1 and remove backward. Okay, remove backward. In the worst case, if I want to delete I equals to 0, if I want to delete in this index, then it will take ON times. So the new array will be like this one. Because we remove the last I, this is the object O. So we will get like this one. Then when you do with your team project, okay, you need to understand how this operation works, and then you need to analyze your PO. So in this case, this array is implementing n the space. Do you know what does it mean by the space? Space. It means how many slots that you need to have to save all the elements. Because we have n elements, of course, the space will be On. So the idea of this one is the same with the time performance, but now we are just analyzing how much space you will consume if you have your data. In most problems, I guess it will be On, but after the mid exam, we will learn some other data structures that the space can be reduced. How can we reduce the space? So the indexing in the element of I, it takes O1. Of course, it's only just indexing the element. Array index 0, so it's only one time. Array index 5, then it's only one time as well. When we want to run the add and remove function, it will run On. Okay, it is in the worst case. Now, there is another things that we need to understand. When we want to add something, when we want to add one more value, okay, if you are doing with the list, I think there is no issue. But if we are using array, when the array is full, okay, how can we enlarge the array? How can we have one more element? If you have one more element, maybe just plus one. But how if you have 1,000 more elements? Then you will have 1,000 times of addition. Of course, there will be a kind of strategy. What will be the best strategy to reduce the complexity? If you have 1 million new data, and then if you want to put into the array, are you going to put one by one, or you want to replace the array with larger one for 1 million times? Yeah, there will be a strategy, what we call as the growable array. So the array can be grown. So this kind of growable array, it is based on the array, what we call as array list. Array list in Java or array list in Python, okay, you know already about lists. But if we are using the specific kind of array, then we can develop one operation or more operations, how we can make it more optimized. So in the previous example, we have add, okay, we have add operation. The add operation contain the index I, comma, O. So we want to insert one new element in the index I, and let it be the object O. But I don't want to specify the index. I just want to add the object O, okay, without an index. And the object will always be at the end. Okay? So if I have an array, I will always put the value at the end, at the end, at the end. So it is growable. The problem is when the array is full. When the array is full, if we already have the n size, and then whenever we want to add one more element, then we need to add by one. We need to add by one, and so on. Okay? So the increment strategy, there are two. Okay? Are you sure that adding by one is good or it is efficient? incremental strategy. The incremental strategy is to increase the size by a constant C. So if I know that I will add one more data, then I will add by one. If I know that I will need 5 more data, then I will add with 5. But there will be another strategy, which is doubling strategy. We want to double size. So if I know that the size is now 10, okay, and then I need to input new element, then I will increase the size with another 10. So the new array size will be 20. If I have 20, and then if it is full, then I will enlarge again with the double, 20. So it will be 40, and so on. So which one is more efficient? So this is an algorithm to add the object O. First, let's check if the T means the size of the array is less, S means the sequence or the array, length minus 1. So if the size is the same with the length minus 1, then let's make a new array of size n, and then we want to put every element from 0 until n minus 1 and put every element of S into the A. After I send all the elements of S into the A, so I can have the S. Okay, I can have the S. Then the S will be the same with the A, and then N can be added by 1, and I will put the S n minus 1 with an object O. Okay. So this the idea to add the object O at the end of the array. So when we try to compare the strategies, okay, what will be the best one? Incremental strategy or doubling strategy? So we need to analyze the total time, or the Tn, needed to perform a series of n at O operation. So if you have n data, okay, so I need to know what is the big O, or how long is the total time to add n number of data. Okay. So we assume that we start with an empty stack represented by an array of size 1. So the stack I will explain in the next PowerPoint. Okay. We call amortized time of an add operation the average time taken by an add over the series of operation. So we call this is amortized time. The amortized time is the total time taken to add n time divided by the number of data. So, for example, let's replace k with n divided by c. So this c is a constant. Okay. So n is the number that you want to add in the array. Let's suppose I want to add 100 more data. Okay, and then let's increase the array size with a constant 10. So if I have 100 more data, add 10 at this moment, and then add another 10, and then add another 10, and then add another 10. Okay, so it means it will be a kind of series. Okay, so the total time of Tn of a series of n operation, okay, then it will be proportional like this one. The first n is, for example, we have like 200 data. Okay, after we have 200 data, I would like to put the constant. So the constant means how many data that you want to input every time when you enlarge the array. So the first is C. So before we have like, if I have another 100 data, okay, and then I would like to increase the array with, for example, 10. So the first will be 10, and the next will be 2 multiplied by 10, and the next will be 3 multiplied by 10, and the next will be 4 multiplied by 10 until k. What is the k? K, it means n divided by c. So if I have another 100 data and then I want to increase the array for every 10, then it means there will be 10 times. So this will be a arithmetic operation. The arithmetic operation will be shortened with this one. So C you can just put as a constant. So C multiplied by 1 plus 2 plus 3 plus 4 until k. And it can be shortened with this equation. Okay? So this is the operation in the arithmetic. Okay? We can make like 1 plus 2 plus 3 plus any number until n. So it will be it's the same with n multiplied by n plus 1 divided by 2. Okay, so you need to understand this mathematics. Okay. So if I put it as a k, if I put this one as a k, then I can just replace with the c multiplied by k plus 1 divided by 2. So this will make us to know that, what is this one? C is a constant. Okay. If it is a constant, then we do not care for the big O notation. So we only care about the n and then k power of 2, because here is k multiplied by k plus 1. If you remember the big O analysis, we just consider the higher order. The lower order we can remove it. So we have O n plus k power of 2. If k and n are more alike numbers, then we can just say that, yeah, it is O n power of 2. Okay. The amortized time of an add operation, then it is O n. Why? What is amortized time? Based on this explanation, the amortized time is the number of add operation, the average time taken by an add over the series of operations. So we have the Tn divided by n. So this On means I have the Tn. The Tn is n power of 2 divided by n. Okay. So n power of 2 divided by n, it becomes n. So the amortized time of an add operation, now it becomes On. Okay. What about the doubling strategy? In the doubling strategy, we want to increase the size based on the geometrical operation or geometric series. So here I can have the k equals to log base 2 n times. You still remember this one? Okay. If I have 2 power of 3 equals to 8. Okay. Then log base 2 of 8, it will be equal to 3. Okay. So if I have n number of data, okay, then the operation will be more likely about 3 times. Okay. So this total time, okay, we can do again with the series. Okay. If I have the n, let's say I want to add 100 more data. Okay, and then I would like to use the log base to n. So it means when I add one more data, then plus 1. If I want to add more data, then grow the array by 2. If I want to add more data, okay, I know that someone wants to add more data. Then let's grow it into more 4 data. In the fourth, okay, I know that this guy would like to have more data. Then I increase into 8 more data or 8 more space. After sometimes, yeah, we can get this is 2 power of k. So this series is, we call it as the geometric series, and we can short it to make like this one, 2 power of k plus 1 minus 1. Okay, and because we have this n, okay, and regardless about the k that we want to get at this proportion, okay, so we have the amortized time, no, sorry, the total time is n time. Okay, so you can simplify this one into the 3n minus 1. Okay, and then because the total time is on, okay, this one is on, sorry, this one is on, then the amortized time will be the Tn divided by n. So On divided by n, then the result will be a constant. Okay. So this result will be a constant whenever we grow the array with the doubling strategy. Is always constant. So you don't need to worry about the complexity. This is the implementation in the dynamic array. I think I will not discuss this in detail because it is embedded in the array uh, in the Python implementation. So I will explain more about the code on Monday. This is about the array, and we know about the type of operations like add and remove, and how if the array is growth. So the next thing that I want to explain is about stack. Oops. I think I need to, sorry, this one I have not updated the concept of stack. Okay. This is one of the important data structure in any programming languages. Okay. In Java, in Python, in C. Yeah, we need to understand how the stack works. So there will be three things that we will learn in this section. We will learn about the abstract data type, and then examples about stack, and how the stack can optimize some complexity of the algorithm. So the idea of stack is the same with what we call as last in, first out. So this is what I explained in the team project PowerPoint. It is good if you want to find the implementation of this algorithm in the warehouse or inventory. So whenever we are doing with the algorithm or with the data structure, we need to know that it has the abstract data types. So we already learned about these things before. The abstract data type contain the data stored, what kind of data that you will store, and then what kind of operation on the data, and then the error condition associated with the operation. Okay, so this ADD always discuss about those three. Okay. So you already learned about the class. Okay, what is class? Okay, a class is containing at least the data members and functions. But when we create an ADD, it's not only about the data or the data members and the functions, but it also includes when some errors occurs. The ADD of the stack, it can be used like for the simple stock trading. I think nowadays, stock is getting more popular. You can use this kind of stack for the stock trading. And some of the data that you may use are like buy or sell. How many stock you want to buy? How many stock you want to sell? Some operations like order buy, order sell. And then those are the parameters like stock, how many stocks do you want, and then the shares, how many lot or something, and what about the price? Or you want to sell, or you want to cancel. Okay, so you want to cancel the order. Some of the error condition might be like if the stock does not exist, or cancel a non-existing order. So maybe you want to cancel your order, but the order does not exist. Okay. So you can define those things in the abstract data types. So the stack ADT is very general of the data structure. We want to use the arbitrary objects. Okay. So this arbitrary object means it can be numbers, or it can be a character, it can be mathematical operators, and etc. And we have the operation like what we already learned on the array: insertion and deletion. Okay. So many of data structure will always have this kind of operations. So let's think this stack is like a spring-loaded bread dispenser. Okay, like this one. Whenever you input one, it will push the spring. If you input another one, it will push again. If you input another one, yeah, it will push again the spring lower and lower and lower. So the idea is the same like that one. We call push. Let's push an object. So if we push an object, it means we want to insert one element. There will be another operation, we call it pop. So pop means we want to remove yeah, if this one is in the top, okay, then we want to remove the top. Some auxiliary stack operation. So this is the additional operation. We want to know the top. The top means the last inserted element. Okay, I want to know the value or the object on the top, but it will not remove. Okay. Or I want to know the length. So how many elements now in the stack? And then there will be a boolean whether it is empty or not. Is empty. If it is true, then the stack is empty. If it is false, then the stack is not empty. So let's see. This is example. I start with the S, and let's assume S is just an empty. Okay. Now I want to push 5. So the S has one element, 5. And then I push 3. Then the stack contains 2 elements, 5, 3. Or I can just put like this kind of chamber, like this one. So 5 inserted here. And then I have 3. Okay. And then if I want to get the length of S, oh, there are 2 elements. Okay, because you know there are 2 elements. I want to pop. So the last element inserted into this array will be removed. So this 3 will be removed. Now we ask whether the S is empty or not. Yeah, false, because we still have one element. And then let's do pop. So when we pop, this item will be removed. Yeah, this item will be removed and now becomes empty. Is empty? Yes, true. Because there is no element. What about if we want to pop? Okay, it will be error. Why? Because no element. Okay. And then let me put one value, 7. So I have 7. Let's push 9. So I have another value, which is 9. I would like to check the top. The top will be 9. Okay, so this will be the top. And then let's push another value, which is 4. So we have 7, 9, and 4. What is the length? The length is 3. Okay, there are 3 elements. Let's pop. So the top element, this is 4. We want to remove it. And then we push. So we have a new element, 6. Okay, 6 on the top. And then if we push 8, we have a new element, 8. And then if I want to pop, it means I want to remove the top, which is 8. Okay, so that's the way to do the step by step with the stack, with the operation push, pop, length is empty, and top. So the ADT at least contain 5 operations. So some applications, yeah, it can be related with the page history in the web browser, or it can be related with the undo sequence in the text editor. So if you are typing in the Microsoft Word, or typing in the PowerPoint, or typing in the Hangul, okay, if you delete and then you want to undo, then it will return back. or other kind of method like chain of method calls. Okay? And some indirect application, yeah, it can be the auxiliary of data structure for other kind of algorithms, and it is a kind of component for other data structures. Okay, I will explain the next um, on Monday. Okay, and as I mentioned before,